Hello and welcome to Foundations in Pre-Cal 10 today. I'm your host, Mrs. Clausen. Today we're going to be talking about surface area and volume of three-dimensional figures. You are going to need your formula sheet that you were provided. It has all of the formulas of everything that you're going to need. You may need to, if you don't remember, just a couple of formulas. So the area of rectangle is length times width. The area of a circle is pi r squared, and the area of a triangle is base times height divided by 2. So those are just a couple of formulas you may want to add on to your formula sheet. Those are two-dimensional figures. We're going to be looking at three-dimensional figures. So the surface area, we're going to look at surface area. Okay, so what that is it is the area of all of the surfaces that make up a 3D figure. So basically, if you were to unfold it, which we call a net, when we unfold it, this right here is a net, we can see that this is made up of three different sized rectangles. I've got the front and the back, the top and the bottom, and the two sides. So for example, the surface area formula for that is 2 length width plus 2 length height plus 2 width height. Okay? Remember that for surface area, our units are always going to be in units squared, such as millimeters squared, inches squared, feet squared, something like that. We are also going to look at the volume of a three-dimensional figure. So think of volume as kind of how much substance it would take to fill up a figure. So if you were going to be filling it with grain or water or whatever, that's its volume, putting things on the inside. And remember that we are always dealing in units cubed when we have volume, so millimeters cubed, centimeters cubed, yards cubed, whatever the case may be. So let's take a look at the two examples below. We're going to calculate the surface area of these two figures. The first figure is called a triangular prism. It doesn't really matter what its name is, but we want to figure out the area of all of the figures that make it up. So if you take a look at it, you can see that it has two triangles and three rectangles that are all different size. So I kind of just like to do that to sort out my information. The triangles, we know that the formula for a triangle is base times height divided by 2, and rectangles are length times width plus length times width times length times width. So if I look at my triangles, so remember that the base and the height have to be perpendicular to one another, so it is in this case. So I know that I've got 2, the base is 4, the height is 3, and I'm going to divide that by 2. Then if I look at the bottom rectangle, that would be 4 by 11. Okay, so I see the bottom as kind of being this guy down here. Then I could look at the slanted side. The slanted side is 5 by 11. And then the back side of that would be 3 by 11. Okay, so if you calculate all of that, put it into your calculator. You can do it all as one, or you can do them individually and add it together, up to you. But you end up with 144. Each of these linear measurements are in centimeters, so the surface area will be centimeters squared. Okay. The second figure is a cone. If you look at your formula sheet, you will see that the formula for the surface area of a cone is pi r squared plus pi rs. So r is the radius, which we have. We know that the radius is 16. S is the slant height, okay? So we're going to have to do a little side calculation because the slant height is this slanted side right here. So if you look, and I take this out of the figure, I have a right-angled triangle, which has a height of 32, and my radius here is 16, so I want to calculate that side there. So we're going to have to use the Pythagorean Theorem. So 32 squared plus 16 squared is equal to the slant height squared. So if I put that in my calculator, I get 1280. And to solve that, I need to square root on both sides. So I end up with a slant height of 35.8. So now I can just go ahead and plug those numbers directly into my formula. The radius is 16 squared plus pi times 16 times that slant height that I calculated, 35.8. Okay, and when I put that in my calculator, I get 2,603.8. The linear measurement is in feet, so my surface area will be feet squared. So that is how I find surface area. Let's look now at volume. So keeping in mind that you could have any of these figures, you have all of the formulas on your formula sheet, so I'm just pulling a few of them out. So this is a triangular prism, and if you look at the formula sheet, it says that the volume is equal to the area of the base times by the height divided by 3. Okay, so I can see that the base of this is a rectangle, so I can figure that out quite easily. The problem is that these red lines here are like the height of the triangles that are on a slant. What we want to do is we want to figure out the height of the pyramid, which would run down through the middle. Okay, so what we need to do is we would need to to figure that out, create a right angled triangle. If you can kind of visualize it being down through the middle, across to the edge, and up the edge of the triangle. And if I do that, I can calculate that height value. We know that this from this diagram is 6. Now, it will be in the middle, and we know that the distance all the way across that side is 5. So then this is 2.5. Now, I'm given the hypotenuse in this case, so it's still Pythagorean theorem, but I'm calculating for A instead of for B. So I'm going to take my hypotenuse squared, subtract my leg squared, will give me my height squared, which gives me 29.75. And then I need to square root to get my height. So I know that the height is 5.45 centimeters. So now I can just go ahead and plug that into my formula. So the area of the base of this, so it's going to be a rectangle, it's going to be 8 times 5 times the height of my pyramid, which is 5.45, divided by 3, gives me 72.7 centimeters cubed. Okay, so I tried to pick examples where there was maybe something a little bit different that you'd have to do. Sometimes you just look directly, plug the numbers into your formula. It's easy peasy lemon squeezy. Okay, this guy is a sphere, so even if you don't know the name, I've given you the picture on your formula sheet, so you can find that the formula there is 4 pi r cubed divided by 3. We are given directly the radius in this picture, so 4 pi times 24 to the power of 3 over 3. So plug that in your calculator. You may, in order to use the power of 3, you may have an exponent of 3. You may have to use the x to the y button. You may have to use the little hat button. So find the one on your calculator to put that power of 3 in there. And when you do that, you get 57,905.8 meters cubed. Okay, let's look now at a couple of examples where we're just rearranging formulas. Okay, so the surface area of a cylinder, so it's surface area, it's a cylinder. The surface area is 156. The radius is 2.5. Find me the height. So if it's the surface area of a cylinder, I'm going to start by writing that formula down. So from your formula sheet, surface area is 2 pi r squared plus 2 pi r h. We're going to put in everything we know. So we know that the surface area is 156, and we know that the radius is 2.5. So I'm substituting that in those two places that it pops up in the formula. Now, sometimes this is overwhelming, but if you remember that these are just numbers, okay? So you're going to take your calculator and you're going to punch each of those in individually and get numbers for them. So if you do that first expression, 2 pi times 2.5 squared, you end up with 39.27. And 2 pi times 2.5 gives you 15.71. So now I just have a two-step equation. I want to isolate h, so I need to undo the adding and subtracting first. So I'm going to subtract 39.27 from both sides. So that gives me, I'm just going to go over here, 116.73 equals 15.71 h, and then I'm going to divide by 15.71 on both sides of my equation, leaving me with the height of my cylinder of 7.4 meters. Okay, so that one's a little bit tricky. But once you, I find, turn these guys into numbers, then it is a lot easier. Okay, this time I have a sphere. It has a surface area of 483. Find me the radius. So I'm going to go to my formula sheet and pull the formula for the surface area of a sphere is 4 pi r squared. and just plug in the numbers that I know. So 483 equals 4 pi r squared. So I want to solve for r. So, I mean, you could again put 4 pi and make it into a number. I'm just going to divide by 4 pi because it's a little neater than making it into a decimal. So if I take 483 and divide it by 4 pi, I get 38.43, ugly decimal number. And then I'm going to square root to solve, giving me 6.2 centimeters. Okay, so you have some practice questions to go through. I want you to practice a few different kinds of shapes, some surface area, some volume, and then you can move on to composite figures.